Hello friends, welcome to our channel. Here we are going to look at problem 670 and 73, number of longest increasing subsequence. First, the method we are going to use is dynamic programming. Our plan is to demonstrate the finer details when writing DP solution in the DP update, right? So there might be some related exercise. For example, here we compute the number of longest increasing subsequence. So a related one is given a list of integers, find the length or the longest increasing subsequence itself, right? So here we are considering subsequence. What about subarray? Actually, if you change this subsequence into subarray, in other words, consecutive pieces, then it turns out to be easier, right? So you can also write using 1D dynamic programming using recursion format. But here I'm going to use tabulation, right? So tabulation sometimes can reveal more details. So the problem statement is rather short, right? So given an integer array nums, so we want to return the number of longest increasing subsequences. So here the subsequence has to be strictly increasing. That's the one. So in example 1, you can see the longest subsequence is of length 4. You can have 1, 3, 4, 7 or 1, 3, 5, 7, right? So for this one, you could only have 5 because each of the longest strictly increasing subsequence must be of single elements. So just because those numbers are the same. So here the length is bounded above by 2000, not very large, right? The numbers can be negative, can be 0 or positive. The answer is guaranteed to fit inside a 32-bit integer. So this is just some consistency, especially these two items. So with that said, let me continue for the coding. So here I want to emphasize our goal. So our goal will be the following. So we want to demonstrate the importance of interpretation in DP initialization. When you initialize that, you should have some interpretation about the terms, right? And then this interpretation basically determines how you do the DP update. So now let's first look at version v1. So what we want to do, first I'm going to get the length of this nums. This is just for convenience. Or you can retrieve this number, this attribute of the nums as you need it, right? So here, let's first put it here. And then I'm going to initialize length. That will be 1 times in. And also I'm going to have a count. So also 1 times in. So here, let me make some annotation about the interpretation. So DPI will be the max length of a valid sequence ending at index I, right? So in other words, we consider sequences that must ending at the index I. So this interpretation is actually very convenient. So similarly, count, not DPI, the length I, right? So count I will be the count of valid maximum length sequences ending at R, right? So initially it might be not the longest one, but when we do iteration, so it will be the longest one, or the right count. So now let's look at the DP update. So here you need to pay attention to this part because this is some point I want to demonstrate. So for I in range n, then here I'm going to look at the one before I. So I'm going to do for j in range I, right? So this range will be from 0 to I minus 1, right? So now what we want to check is if nums j is less than nums I strictly. This means that in the subsequence ending at nums j, so we can append them with nums I. This forms a longer in the sense that it increments length by 1 valid subsequence. So then if length of j plus 1 is greater than length of I, right? So then the count will count the length of previous length will be actually should be overwrite. So length I will be at least, actually length j plus 1. So here we need to make count to be 0. If you look at this prediction interpretation, it will be the valid max sequence. But now actually the length of the at I actually changed, right? So this part is crucial. If you write like this, in other words, we look at the j's before I, right? So then actually afterwards, you need to also update the length count, right? So another one is that if, let me write if or else if, both are okay. If length j plus 1 equals length I. So in this case, we don't need to overwrite the count I, but we need to not set to be 0, but we need to increment that by those of count j, right? So then after this DP update, so we can get the maximum length. So this will be max of length, right? And then what? How to get the result? So basically, the result will be 0, and then we are going to do an iteration for range I, right? If length I equals the max length, right? And then the result shall be incremented by count I. And then finally, we just need to return the result. So here, result. This forms version v1. Now let's do a test. Yeah, it passes the two test cases. So now let's look at the generic case. Yeah, it passes the generic cases. So here, let me make some comment. So here you can write else if. else if. So you run it. Oh no. So here, let's see. This no matter what, we should do this. You cannot write. So I mean, cannot write else if. So you always need to do this. But you can do something like this. So you can do. So you can first set. Make. Let me copy this one to demonstrate some problem. So here, this is the version v1. So still, this is also version v1. But let me. So you can you can do something like this. So after you, for each of those, after you set the you set all of those, so you can do something like this for j. For j in a range I, right? And then you do this. So this will be okay. Let me run it. Yeah. Let's see what's the problem. Let's see. Here. I guess, yeah. Let's see. For j in range I. So for after this iteration, actually you get all those, and then you need still overwrite that. So here we have length I, and yeah, it's better to put it in the original one. So let's see. Yeah, this is the point. Actually, I got a little bit confused. So, but this is the complete for version v1. So now let me write version v2. But I'm going to use similar interpretations. However, I want to iterate differently. So this will address this part. Actually, version v1, if you write like this, so this part is crucial, especially this part and this part. If you're in a hurry, you might write the not the logically correct and complete solution. Now let's look at the version v2 and see the difference. So what I want to do is this. I'm going to, for j, I'm going to go to this. For j, I write I and n, right? So it might be j equals I. But if j equals I check this condition. It's impossible. Essentially, we are doing j I plus 1, right? So let's write it like this. It does not matter. So or like you write like this. Let me first put here, and then for this one, because G is actually larger, always larger than I, so the length will not be affected, and you don't need to do this. So we delete this part, right? And then what we want to do is else if. This will be right? So if this, let me write here, else if, and then delete this part, right? So then you the G is can't increment by that of I. So here, let's see, I also need to if length I plus 1 equals is greater than that of length G. So I'm going to do G and the I, right? And then if length I plus 1, so we should have that of G, then the count of G should be incremented by 1, right? So then this will be the same, right? So here the difference is that I'm considering the latter part. That's why in our beginning, so we want to see, we demonstrate the importance of interpretation of the initialization and also the DP update format. So these two actually are almost identical, but you know, here we consider the previous ones, but here we consider the latter ones. Let me first do a test and then further comment. We should first guarantee it passes the test. Yeah, let's see what's the problem. So here we have n equals length nums, and then length, and then count, right? So then for I in range n, for j in range, yeah, if nums I less than and nums j. So here also tells us if you copy something, you need to make sure you made modifications in all the necessary places. So now let's run it. Yeah, it passes the two test cases. So now let's submit for generic case. That's wrong. Let's see what's the problem. So here we have I less than j. If length I plus 1 is greater than length, so length j will be length I plus 1. Oh, so here I forgot the count. The count j should be should be equals count of I. So this also, you know, we inherit from this j. So here is equality, and here is a increment. So this is set the thing count j to be count I. So this here is increment. This is the important. So now let me run it again. This should pass, and then it submit. It passed all the cases. So that's basically about it for the second version. So actually, from the mistakes I made, you might notice the critical importance of the DP update format, right? So here, as we stated at the very beginning, so we want to demonstrate some finer details when writing DP solution, right? So overall, I would say for this problem, now if we do it, it's a rather classic problem. Solving it is not a problem at all, but you know, writing it in a clean and logically correct and complete fashion, it still needs some thoughts, right? So that's a comment. Another comment is that we have a big DP playlist in our channel. You're welcome to check out those videos and do some practices. With that said, thank you for watching.